This video will discuss 3 SeqNinja functions that are particularly useful for handling large data sets. In this example, we'll start with a folder of 47 GenBank files comprising 3 genuses and 12 species of bacterial genomes. Our goal is to find the shortest CDS features in the Vibrio genus that produce glutamate decarboxylase. There are 3 templates that are particularly useful for large data sets, and we'll be using all 3 of these templates in today's example. Collect sequences is used to combine multiple sequence sets into a single item, which can be either a file or a variable. Split sequences is used to separate the single file into multiple files. And sample sequences is used to find the subset of samples that meet a specified criterion. Collect sequences and split sequences are functions that support file patterns. Here's our SeqNinja strategy. Using the Vibrio genomes only, we'll find all the CDS features that produce glutamate decarboxylase, then discover which of these features are the shortest, and save them as separate FASTA files. On the right you can see the templates that will be used to perform each of these steps. The first template that we're going to use is Collect Sequences, so I'll click on that. And notice that both the collect and the extract templates are applied. The first thing I need to change is the file pattern. In the first part of the edit pattern area, I'm going to put the bacterial genomes folder, and then Vibrio wildcard GBK shows that I want it to look only for files beginning with the word Vibrio and that are in the GenBank format. I'm going to save this as variable A. Now in the extract step, I'm going to take my collected sequences, A, and look for CDS features, and I'm going to filter those so that I look for CDS features whose product consists of glutamate decarboxylase. Note that it has a space for me to save the results as a file. However, I instead want to save the results as a variable. So I'll right-click and choose Assign to Variable, and this will be variable B. The next thing I want to do is automatically find out which of these CDS features that we have defined as variable B are the shortest. To do this, I will drag and drop the Sample Sequences template to the bottom. I'm looking for the smallest CDS features, so I'm going to make a maximum length of 1500. I'll delete the next filter because we only need the one. I'm not going to input a sequence file, but instead input variable B that we saved above. To do this, I'll just delete the sequence file and confirm the deletion, and then from these buttons I can choose variable and type in variable B, which we defined above. That's going to be the input for this step. And in the Save Results As area, again, I do not want to save it yet as a file, I just want to save it as a variable. So I'll right-click in the blue area and choose Assign to Variable, and we'll call this variable C. And the last thing we're going to do is to take all of the CDS features that meet our criteria and split them into individual FASTA files. To do this, I need to add the Split Sequences template to the bottom, and again, instead of choosing a sequence, I'm going to delete that and choose a variable and enter the variable C that we saved above. The final step is to specify which output pattern we'd like to use. In the output pattern area, you can see that new underscore and an asterisk, which is a wildcard, appears, followed by the extension GBK. When SeqNinja runs the program, the wildcard will be replaced by the accession number of the related file. In this case, I'm going to edit the pattern and the extension. Starting from the top, you can see that the Collect template is used to look in the Bacterial Genomes folder and find all of the files beginning with Vibrio and ending with the GenBank extension. Those files are saved under the sequence variable A. In the next step, Extract, we're going to start with the files found in A and extract the CDS features who have a product of glutamate decarboxylase. We're going to then save those as variable B. The third step, we're going to use B as our input, and we're going to find all of the CDS features that were already found that match the new criterion of having a maximum length of 1500 base pairs. Those will then be saved under sequence variable C. And finally, C will be used as an input in the split sequence set template, and All of the found CDS features will be split into individual sequence files, which end with the words meets all criteria.fasta. Now all I have to do is click the Run button for us to get our results. And now the run has been successfully completed. SeqNinja provides links to the location of our results data. Just click on there and we can go see our results. And there we have the 3 FASTA files that meet all of our criteria. To learn more about working with large datasets in SeqNinja, or for information about any of our other applications, please visit our website at www.dnastar.com or contact us at support@dnastar.com.